All right, in this question, we'll be looking at the diagram shows an experiment to produce a stationary wave in an air column. A tuning fork placed above the column vibrates and produces a sound wave. The length of the air column can be varied by altering the volume of water in the tube. The tube is filled and then water is allowed to run out of it. The first two stationary waves occur when the air column lengths are 0.14 and 0.42 meters. What is the wavelength of the sound wave? So we really kind of want to think about maybe, okay, the air column length. So here's the air column, here's the water column. So when the air column is only 0.14, that means it's mostly full of water. So let me sort of sketch that here. It's mostly full of water. There's only 0.14 meters of air, and we would get this kind of a wave, a node at the water-air interface and an antinode at the opening here. That antinode is where the particles are moving the most, and that's where it's going to resonate with this tuning fork. So the movement of the air particles sort of resonates the tuning fork, and that in turn sort of makes a loud sound. So the tuning fork is used to sort of detect when we've got a stationary wave, right? It's going to sort of oscillate, it's going to resonate. So there's the waveform of our fundamental frequency, right? So the lowest harmonic. The next one, it says, is 0.42. So we're required to have this sort of node, antinode. What's the next one going to look like? So let's bring the water down a bit. And now it's going to go open, close, open. So it's like this one now. So this, remember, is only a fourth of a wave. We've got 1/4 of a wavelength here. Here we've got, there's our fourth, there's our half a wave, and so it's 3/4. So this harmonic is 3/4 of a wavelength, and this one corresponds to a column of air 0.42 meters. So this should be enough to deduce the wavelength now. We just have to kind of think through it very, very clearly. The difference between 0.42 and 0.14, right? The difference in these air columns is how much? Well, it's the difference in how much waves we've got. If this is 1/4 of a wave and this is 3/4 of a wave, then the difference between these heights is going to be equal to 3/4 of a wave minus 1/4 of a wave. That's 2/4 of a wave, or half a wavelength. So half a wavelength is how long? 0.42 minus 0.14. Got 0.28 units are meters, so 28 centimeters is half a wave. So if I double both sides, I can deduce the wavelength as 0.56 meters. So I see